Today we're going to be talking about how to add and subtract with polynomials. The concept on how to do this is pretty straightforward. If you want to add or subtract with polynomials, the key thing you're looking for is like terms. You want to be able to combine like terms only. Okay? When we say like terms, what I mean by that is they need to be exactly alike, meaning both the variables and the exponents on those variables have to be exactly the same. If there's any difference, then you're not actually able to combine them. For example, show you what I mean by that. Let's say you were asked, example 1 here, let's say you were asked to take the polynomials 5x squared plus x minus 7, and you were asked to combine that to add it to the polynomial negative 3x squared minus 6x minus 1. Well, first off, you'll notice that they are shown in parentheses there. And that's because we do have two separate polynomials that we're being asked to add. In this case, it's just addition. We know addition is commutative, meaning it doesn't matter what order you do things in, right? I mean, 2 plus 3 is the same as 3 plus 2. So because it's addition, we don't really need those parentheses. We can effectively just drop those parentheses off and rewrite everything as one large problem. Although maybe you want to put that one in parentheses so that the plus and the minus are separate, but you know, same idea otherwise. Now that we've got rid of those parentheses and we can combine everything, we want to look for like terms. When I look at my first term here, I see 5x squared. So what I'm interested in there is I see not only do I have a variable of x with that number of 5, but it is an x to the second power, an x squared. If I want to be able to combine this 5x squared with a like term, that would mean that term will also have to have an x that happens to be squared to the second power. It can't have anything extra either, meaning if it was an x squared but it also had a y with it, that would be a problem. So as you've probably already noticed, we have this term right here of negative 3x squared. It has an x, and that x is also to the second power. Though that makes these like terms. So then the way we're going to combine them is we're simply going to add the coefficients. Remember, coefficients meaning the numbers in front of the variables. So I've got a 5, and I've got a negative 3. 5 minus 3, or 5 plus a negative 3, would be positive 2. So we have a 2x squared. Okay, so then I'd move on. I'd look at my next term in line. Well, the next term I have is an x, just an x. So not an x squared, not an x to the third, it's just an x, or x to the first power, right? Do remember, if you are not shown a coefficient, there is always an invisible 1 in front of a variable, right? If they don't show you a number in front of the variable, there's always a 1 there. So effectively we're dealing with a 1x right now. So I want to look through the rest of this problem and see, do I have any other terms that have just an x to the first power? And yes, certainly we have a negative 6x here. Alright, those are like terms because they both have a single x, just an x to the first power. So 1 minus 6, or 1 plus a negative 6, would be negative 5. So we have a negative 5x. And then finally, I see that I have a negative 7, just a constant, no variables with it whatsoever. I also have a negative 1 over here that again is just a constant, has no variables with it whatsoever. So those are like terms because they both have no variables at all. Negative 7 minus 1, or negative 7 plus a negative 1, would be negative 8. And that would be our answer for this example. That's all you have to do to add and subtract polynomials. You're just looking for like terms, looking to combine like terms. Okay? Let's try another example. Let's say I give you the polynomial 3x to the third plus 8x squared minus x minus 5. And then this time I'm going to ask you to subtract it by the polynomial 5x to the third minus x squared plus 17. Overall, this is going to be the same concept with just a small extra wrinkle. That wrinkle being we're subtracting instead of adding. So now that it's subtraction, we do care about these parentheses. That's why I'm giving you parentheses for these polynomials. Because subtraction, unlike addition, does not work the same both ways. Right? If I ask you to take 3 minus 2, that is not the same as 2 minus 3. Right? You have to care which number comes first and which number comes second. Likewise, we need to care in this problem which polynomial comes first and which polynomial comes second. The first polynomial, we don't need to change anything with it, meaning we can literally just drop the parentheses off and rewrite all of this. No change, nothing special. But for the second parentheses, we are supposed to be subtracting by this second parentheses, the 5x to the third minus x squared plus 17. Every single term has to be subtracted. And the easiest way to do that would be to simply distribute this negative to everything inside the parentheses, meaning it's effectively distributing a negative 1. So negative 1 times 5x to the third would be a negative 5x to the third. Negative 1 times a negative x squared would actually make this become a positive x squared, because remember, a negative times a negative is a positive. Negative 1 times 17 would be a negative 17. You will notice that now that we distributed this negative, I dropped the parentheses off. That's how you get rid of the parentheses, is by distributing that negative. So now that we've got the parentheses done, taken care of, now we're ready to go ahead and be able to combine all my like terms together. So we will start with our first term, which is a 3x to the third. If I'm going to be able to combine this with anything, I will need to find another term that not only has an x, but also specifically has an x to the third power. Well, I do see that I have a negative 5x to the third. So, take the coefficients, the numbers in front, and combine those. We have a 3 and a negative 5. 3 minus 5, or 3 plus a negative 5, would be negative, oops, sorry, I forgot to change off the highlighter, would give me a negative 2x to the third. 3 minus 5, or 3 plus a negative 5, would give me a negative 2x to the third. Then I'm moving on. I see an 8x squared. So I'm looking to see if there are any other terms that have an x squared. So not just an x, but also have an x squared. Well, certainly we do have one here. This is another x squared. Remember, like we talked about in the last example, if they don't show you a coefficient, a number in front of the variable, there's always an invisible 1 there. So 8 plus 1 would give us 9x squared. For my next term, I see that I only have a single negative x. Right? I do have a negative x right here. I don't see any other x terms in the problem. Since there's no other terms that have simply an x to the first, I just have to rewrite this. I do see that I have both a negative 5 and a negative 17. Since those are both constants, both terms with no variables whatsoever, I can combine those. Negative 5 minus 17, or negative 5 plus negative 17, would be a negative 22. This would be our answer.